Hope you're also joining the second stream. I can see it, but I hope Jan is rocking it and you're getting as much value as possible. Also, thank you for the questions in the chat. Also to you, Martin, that you asked earlier in the chat. Like, I think that's really funny. Why one needs to travel somewhere if this is an online conference? Indeed, it is. But it's so much cooler if I have to wait backstage. I can say like where they're working on the screen and making sure that the speaker pops up. It's a much cooler story just to imagine, because it's digital, and of course we're craving also back to go to the physical stage. But it's just cooler to imagine that the speaker arrives in the private jet and then takes the taxi and is coming in, and there's crowd outside taking pictures, and then boom, they come in the backstage and they come here live. I think that's just, my opinion, a cooler story than to trying to figure out how to share the screen. That's the reason I use that. So hopefully that answers your question. And like I said, the last speaker, I'm checking my backstage, Vladimir, if he's there, or else it will be very awkward to announce him and then it goes quiet. And the last speaker of this day, bear with me, I know this is for people in Europe, it's evening, you might get hungry or already eating. Bon appetit if that's the case. He's going to talk about event-driven programming with Azure Cloud, talking about Microsoft Azure new features, build scalable serverless. It's a word I've been hearing for the last 2 days, serverless, event-driven applications. So he's already normally sharing his screen or something is happening. So I hope it's going all right. He is Vladimir, and here we go with the names. It's challenging afternoon's name, so I'm going to give it a try. Vladimir Hlavacek. Hopefully,
yeah, that's fine.
Yeah, that's fine. Awesome. Okay. Hlavacek, Senior Tech Architect at Accenture, and you have the honor, my friend, to close off this second day of OpenSlava. So without further ado, the stage is yours. Take it away.
Yeah, awesome. Thanks a lot. My name is Vladimir Hlavacek, and I work at Accenture for quite some while, like 12 years already. And currently, I'm engaged in one of our banking clients, where I lead the innovation team with very cool technology, and we are building very cool products for this client, which actually have the possibility to affect how they evolve in the environment, and how they can really apply it to make maybe all the world better. So which I really like. I'm working mainly recently in Azure Cloud, but I have experience also with other clouds. So I will actually give some of the comparison of the things that I'm checking. So let's maybe start with what we are going to talk about in my presentation, right? So I would give a little bit of introduction on how do we build an event-driven applications and what they are, how they work, and we will focus more on the front end. And especially as Azure is coming with new services for real-time front-end communication, we will take a look at this one, and also we will show a real application. How does it work with this service? And we can play around, and I will show you some code which you can also use. Cool. So first, let's start a little bit. What are actually events good for in your applications, right? So if you think about it from an application perspective, what you can build, right? So you can build really real-time applications, so like chats, bot applications, like was mentioned in the previous presentation, games, editors, Office 365. I mean, you name it. All of these applications really have real-time requirements. I mean, they are web applications, but they need to communicate in real time, which means basically they need to pass and receive events into the browser, right? So they typically need some communication either between users of different, which are connected to different browsers, different part of the system, or communication between microservices, for example, when we actually synchronize the state between different microservices using events, right? So with this can actually lead to some advanced patterns, or for example, to stream data processing, where you have some sort of event stream, maybe in Kafka or other topics. You use Spark, other platforms to do real stream processing of the events and analytics, right? Also, what you can do with events is actually some more advanced patterns like command query request segregation or event sourcing, which really decouples your application and makes it more resilient and more scalable in the future, right? So this is all that events are actually good for and which you can use them, right? And how typical architecture of an event-driven application looks like, right? I mean, if you start building an application, it might be in the beginning just a browser and a microservice in behind, just a front end and back end, and this is typical when you start building something, right? So that's the beginning. But then once you actually want to have your data being passed to other parties, to other services, other apps, what you are typically doing is you publish your events into some event stream. This, I don't want to talk about technologies. We'll talk about technologies later, but that's like some sort of really hub which is taking all your events and having them on one place and allowing them to consume. And this is actually consumed then by other parties, right? So it might be other microservices, either storing it in their database, doing some processing, or they could actually send it to a specific front end, right? So you might have different front ends connected for different microservices, and they might get updates based on how the communication is happening. And if you have this, I mean, you start with this, you typically also do some storing of the events, and very good is to basically store it into some sort of data lake where you can actually build additional functionality over this, right? So you can analyze the events. You can, for example, train machine learning models, detect anomalies, right? So in your user behavior or in the collected data, you can do reporting or analytics use cases based on what you actually extracted from the events. So in this presentation, we will look a little bit more into how the front-end part and microservice part actually communicates with events. So we'll not focus that much on the rest, but I mean, you can dive into that a little bit. So when you think about it, how front-end can actually act as an event source or as an event listener, right? So first, it can actually stream events. I mean, I'm talking about real-time events and not like maybe just calling a REST API and so on, right? So with this, I mean really sending data via the real-time communication channel, might it be WebSockets or something else. But typically problem with this is front end actually needs a request reply semantics, right? So you send something to the backend and you actually expect a reply. For example, you create an order and you expect that the backend will confirm, okay, I have actually created the order, and you actually want to do something more, right? So you show the list of the orders and so on, right? So in this type of communication, you really typically need like sending event and receiving an event back on the reply. And thing is, with this type of communication is actually REST or GraphQL typically already good enough, right? So if you think about it, if you have events, you first need some sort of distribution of the events on the backend to tell, okay, this event is consumed by this service and so on. And you already have this kind of functionality or this kind of semantics available by REST services. So for example, if you say create, if you say put on a URL, it will create you an entity in the backend, right? And it will directly call your microservice and your configured route in Express or Spring, right? So it depends what you are using. And also there is this reply channel where you just reply with the response to the front end and you have it. So in this kind of scenarios, you typically don't really need a real-time communication channel where you actually where you actually fully stream the data to the backend, right? So on the other hand, you also still need REST and GraphQL, even if you are building such functionality, because what typically happens, users can actually reload the screen, and you need to reload the state which was there before the user actually was in the browser, right? Or for example, he sends the URL to a different user or opens it on his mobile and so on, and you want to reload the state, right? And for these, again, REST and GraphQL are actually, I would say, good enough. They are already there, they are proven, right? So how this would look like, and here I will actually introduce a very common component for real-time communication with the browser. You typically actually have some sort of gateway that is kind of handling the communication with real-time for you, meaning what it does. I mean, it manages the connections It may, for example, do groups of users. It may have commands like send to everyone, send to a specific use, specific connection, and so on, right? So this kind of functionality is typically provided by some architectural component. Let's call it gateway for now, which is handling like all of this, the connection setting, connection and scaling of the connections and so on. And in your microservice or in your front end, you actually don't care about this too much. You just connect to this gateway and let it do its job, right? So if we are talking about like really sending events from the front end, this is how it would look like. So you send them from the as requests, and you expect the reply. So, but what you can also do, you can actually use front end mainly as an event recipient, and this is, I would say, more useful and more typical case. Where you are typically just recipient for the data, right? So you are receiving the data from the backend, and you update your front end based on what is happening. Maybe in a different microservice, maybe in a different database, maybe in a change done by different users. For example, if you have Office 365 documents edited by multiple users, right? So that's the case where you actually receive notifications about the changes that were done by other users. So, I mean, these notifications, these events that you are receiving, they can directly carry the data, or what they can do is they will just tell you there's something new, and please refresh your content from the backend, right? So all that you will do is you will just call a refresh when an event happens, and you don't, I mean, you get the fresh data. How this typically looks like is that you still have some sort of REST or GraphQL channels, right? So you have your request reply, and you are actually receiving events via the gateway back to your sorry for that, back to your front end, and you are reacting on that. What really changes with this is how you actually handle the front end state. For example, if you have React, right? So you have these use state hooks, and you have like set state, and then what really changes if you have notifications is how this is handled, and how these notifications are put back into the front end state, right? So if you have a REST communication, this is maybe the most common, right? So you send the request, create, update, delete something, and then you fetch the records back as like another function, and update the front end state, right? So this is how it might look like, yeah, in a very small function, right? So you create something, and once it's done, you actually want to show the current state, and you reload all the entries which are shown on the screen, right? Or you maybe load the current page or something like that. So this is what happens with like REST communication. What is the disadvantages is that basically you almost every time load the full state, right? So you reload all the records, and maybe that's like, if you have too many clients, right, that's like overloading your backend also. And you of course may actually have an old state. I mean, not in this moment, but because you don't have event updates from other users, you actually may have a state which was updated already by someone else, and you don't get it into your browser unless the user actually refreshes it or reloads the screen or goes somewhere else, right? So what is changed in case you actually have a notification or like a real-time communication channel that's streaming updates into your front end, and we will show this a little bit, is that what you do is you basically on messages on this real-time communication channel, you are actually directly updating the state. What is happening? So for example, if there are new entries coming, I will directly update them into the state, right? And I can actually decouple this a little bit from my front-end components, from the components that are doing the requests. And here I have just the notification and just the current state I'm building from the events, right? And the rest, actually, all it does is just sending create, update, deletes for like modifications, and it doesn't care about like, okay, I need to reload the state, because he knows that I will just receive the events, right? So I don't need to do that. And on the other hand, there are still some disadvantages, right? You will still need REST endpoints for loading the current state, like a list of entries from the backend or so. because user just reloads the screen, right? And or maybe he goes to the next page and so on. So in these cases, you still need a channel where you actually load the data and put it into the state in the front end with like REST endpoints. Okay, so let's maybe talk about a little bit about technology choices that you actually have for real-time communication into the front end, right? So if we are talking about the communication technology itself, I mean, WebSockets are probably most known. It's an HTML5 API, and that's available. You can use it, right? So you have also WebSockets backend, frontend. Kind of similar is servers and events, although it's a different technology and maybe a little bit better with firewalls and so on, because WebSockets are typically blocked, especially in like banking environments and so on. So servers and events may be a little bit better there, but it's also different HTML5 API. So there is the event source front-end API for communicating with them. Then there is actually a long polling, which is the server kind of instantiating a long HTTP connection and passing that to the front end and sending the data via it. So with this one, it's maybe this was even there before WebSocket and servers and events, but it just doesn't have such nice APIs. And also, I mean, it's good for like older browsers if you need to support them. But nowadays, WebSockets and servers and events are probably the technology to go to. And of course, I had to mention this. Periodic refreshes, like cheap man's real-time communication. You will just have a set timeout in your front end every minute or so. Refresh the data from the backend, and you will get a fresh state, right? And so for the user, actually, it might seem as real time, but in the end, yeah, this is something that you typically don't want to use, right? Okay, so if we want to talk about like the frameworks or like tools that can actually support you with this, this will be not an exhaustive list, right? So I'm actually showing the frameworks that I've used in my career in some occasions, right? So maybe what you already know is Socket.io, right? So Socket.io is actually a small framework which you can put into your application, and it handles the real-time communication basically for you, right? The others are Reactive Interaction Gateway. That's an Accenture tool, which is based on Elixir. And it's if you want to do some real-time communication to the front end, I really advise you to check it out. It's really acting as this gateway, while Socket.io is typically part of your microservice, right? And it's built in. Both of these can be scaled very good. On the other hand, you have to manage them yourself typically. Then there are like tools which are available on the cloud solutions, right? So for example, you can do WebSockets on the API gateway with a very nice way, like where you have serverless communication and you can talk with that, right? So that's one possibility. And the other one is SignalR, which is more like a .NET C# friendly solution when I checked it, which is available on Azure. And nowadays they are introducing a new service on Azure, which is called Azure Web Apps. And this service I would actually like to show you because I think it's quite cool. It's still kind of a new kit on the block. So let's talk a little bit about what it offers, right? So it's really, as I mentioned, it's really this gateway for the real-time front-end communication. You leave the WebSocket communication to or the real-time communication to Web Apps Up, and your microservices or your front-end doesn't need to handle it that much. It currently is in preview, right? This means there are, for example, no like SLAs, or maybe the performance is not really good and all the features might not be supported and so on. But it will get as a real service very soon. So that's why I maybe decided to take a look at it. It currently supports only WebSockets, right? So that's the technology it's using. What is kind of nice is that you actually can build the backends for like the microservices behind it in many different ways, right? So you can either go serverless with C# or JavaScript, or you can actually use SDKs or APIs which are available, for example, for Python or Java, right? So you can build even your application in Java without serverless if you want to. What it is on the front end, it's actually very easy, right? So you just use the standard WebSockets API. There is no library or something that you are forced to use. with web PubSub, and I will show you this is actually very easy to use. What is also nice is the client string subprotocol, so you can actually have some subprotocol for the messages that you are sending, and with some edit functionality. We will talk about this a little bit later. How actually Azure PubSub is working, right? So you have a couple of things. You can establish the connection. This is typically happening. First, you call your REST API, and the REST API actually is using the web PubSub APIs in some way to get you the connection settings, right? So this means you need like an access key and the URL where to connect from your front end, and also the role management and authentication is actually handled on this negotiation calls to your REST API. So if you want to protect your WebSockets connections, you basically do authentication on this API negotiate, and actually issue access tokens depending on like your user rights and so on. And then you pass this URL to the front end, and all the front end needs to do is just make a WebSocket with the URL. If it has that, it can actually send messages. So you send messages directly to the PubSub API, and this one is actually triggering via webhook your REST API. So basically, it's for every message you get a webhook where it is streaming your calls, right? Your events. Or you can actually send messages, right, from the REST API to the front end via some send API calls. You can send to a specific connection. You can send to all, right? So this all is available. What I mentioned is also the client string subprotocols. So this one is actually quite interesting because they have really protocols for web service messages with some edit functionality, right? And currently there are two of these supported. One of them is JSON and one of them is protobuf. So if you want to really have the performance and binary communication, you might use protobuf. In my example, I use JSON because it's simpler. And what I really like that it's adding, for example, this like you can have like groups of your WebSocket connections, and you can actually have group membership. So you can build functionality around that, like for example, have users members of the groups and receive messages just in that group and so on, right? And yeah, so you can leave, join, and there's no need basically to build this custom function. How this application looks like? Well, there is a static website which is serving the front end, and there is a Azure Functions API plus a database and the web PubSub, right? So this is all that there is, and I will show you a little bit like what my sample application is doing. So let me try that. I'll go back here a little bit. So my application is actually something which so I would like to share a list of entries with someone and actually allow it to build this list, right? So for example, I would like to build a list for hiking trip to High Tatras. So I will create that, and okay, now it's getting slow. So I have my list created, and I will actually open a new window with the same list entry, which is available. And now what I can actually do is just build the list of the things that we need to pack together, right? So we want to take, I don't know, backpack. We want to take, this guy will take a torch, or this guy will take I don't know, tent. And you see, I mean, I'm updating the entries on one UI, and it's actually being streamed to the others, right? So what I'm actually doing is I have an ID of the lists, and this I use as a group for the users, and each group is basically sharing the messages between each other and sending the messages. And now I'd like to show you the code actually how this is really done. So we will actually start with the front end where we do the WebSocket connection, right? So this I have extracted basically as a hook in React, and what we are doing is we are getting the WebSocket URL. This is the call to the negotiate API, and what we're doing, we are just instantiating the WebSocket. This is standard HTML5 API. Really nothing fancy, nothing serious. But interesting is these subprotocols, which actually tells Azure PubSub that I would like to use it, right? And now what I can do, right? I can actually, when I connect, I would actually like to join the group based on the list ID. So, and how you do that is basically just send messages to this WebSocket connection. So again, no special API, just special message format that you are using. So I'm saying I want to join the group with the specific list ID. And the other thing that I'm doing, I'm actually receiving events where I'm listening when I'm getting the event, and depending on the event, okay, I will get a message. And depending on the event, I will actually either I can delete or I can add a new entry into my list, right? So I'm not sure. Yeah, I haven't tried it. Yeah, so but there is actually a delete button which kind of removes the items for all the users that are connected, right? Again via the events, right? And so let's take a look a little bit in the backend how it actually looks like. And here we will start with the negotiate function. This is implemented as Azure Functions, right? So in Azure Functions, you have actually the bindings, which are telling you, okay, I want to use HTTP maybe, or I want to use a database and actually get data from the database into my endpoint and so on, right? So all of this you do via the bindings. Here I have just a standard one. I actually had to use it because I needed to connect. Also to pass some roles to the creation of the connection. So basically, what I'm using is I just import the PubSub API. So this is the client that's it. So this is the API that's available within the like Node.js library. And what I'm doing is, I need a connection string to PubSub, the general one, the key with keys, everything. And then what I'm doing is I'm getting an authentication token for this specific connection with the specific user rights. And then I'm just sending this token to the front end, which is then creating this WebSocket connection. More interesting is what actually happens, for example, on create of entries. And here actually, what I would like to show is that we actually have much more bindings, right? So what is nice about these bindings, for example, that you can query data from Azure Cosmos DB. So what I'm doing, I'm actually getting the list ID, and I actually can also insert data, right? So with my binding, I can actually put out some messages and put it into the database, right? So only thing here, if you see, I actually don't have any special API, any Cosmos DB API or something. I'm just passing the bindings as a list entry. I'm creating this one, and the binding will actually take care of inserting that into the database. What is interesting is that I'm actually not sending any events here. This is because I will show it a little bit in the presentation. This is because, I mean, how you can do this like events, right? So you can create an entry and send it to a PubSub and also create into the database. But the problem with this is that this is not really a stable pattern, because, for example, the function might fail if you after you wrote to the database, right? So this is like the distributed transaction problem that you would like to have. So you would like to send data to two remote systems, and one might fail and so on, right? So there are many ways how to actually resolve this. The one which I like is more like the patterns like Outbox pattern and so on, where you create an entry into the database, then you have a trigger on the database, which is then communicating with the PubSub, right? So all of these microservices have just one single external service which they are communicating with, and which makes it which basically they can handle the exceptions. They don't need like synchronizing between two different resources, and this way actually it works, right? So if we look at the trigger that's being there, right? So all it has is basically a trigger for the collection in the Cosmos DB, and also we have a binding for the web PubSub, right? So we can use this to send the messages out. And what we are doing is we receive the document in the binding in the parameter, and what we are doing is we are sending this to a group where as a JSON, and the group is actually the ID of the list, right? So we send the data to all frontend who are sharing this ID of the list which we created in the beginning. yeah, so that's basically almost it. How you can talk with web PubSub, right? So even this I would say we talked a little bit also about some advanced functionality like this subprotocols, which, for example, on Azure, sorry, on AWS with the AWS Gateway, I haven't seen such functionality, but maybe it's now already available. But I like it that is present here. Okay, and that actually would be almost it for my presentation, right? So what I would like to take, so what you can take from this presentation is really that event-driven communication is typically required for any larger frontend. That's part of like many microservices where you would like to get updates from other parties and so on, or updates from backend system, right? And we talked about the patterns that are there for communication. And we also discussed some alternatives like which you can use, and give an example of a real application which can work with events in Azure PubSub. Okay, and with that, I would be happy to actually end my presentation. Thank you very much for listening, and happy to answer any questions.
All right, Vladimir, thank you very much. The last speaker of the day, wrapping it up. Some people saying welcome back. So you have been, of course, with OpenSlava before. Thank you for closing off this second day. And we are looking at the time. The type of question. Let's see if there are any. People are probably, luckily it's in the chat. I would say people can't talk anymore because their mouth is full with dinner. If you're in Europe somewhere. Yeah, there you go. So we're getting late. I have a small delay. Let's see what is coming. If not, it's also okay. It has been a really cool day. Not for now, which is okay. Thank you so much, Vladimir, for the presentation, for closing this off, for being with us at 7, sharing it with us, the event-driven program with Azure Cloud. I hope they learned a lot. They got value out of it, and I hope to see you. Let's say it. I don't want to jinx it, but let's hope to
in
see
person
you again in person. But we'll see. But let's keep the fingers crossed. I would like to thank you. Enjoy your evening. I don't know where you are, but if it looks like it's evening, enjoy your evening, and hope to see you soon at another OpenSlava.
Thank you very much. Yeah, see you there. Bye-bye.
And for the rest of you also looking, of course, it's the end of day 2. It's been a long day, but an insightful day. I hope you also enjoyed the stream number 2. And the only thing that remains for me, for the people here on YouTube, Facebook, on the VSF, walking out with their 3D puppet, is to close off this day. Thank you so much for being here, for networking, talking to the partners, for the people in the chat. Really appreciate you engaging. Really love it. Like I said, stream 2, I hope it went well. Jan, his first time hosting. I hope he gets the taste for it and that you showed him a lot of love and that he might come back in a future OpenSlava. So let's look forward to day 3. It's 3 days, it's going fast, but tomorrow we have another day or afternoon, evening, and we're going to talk about digital. We talked about the business part yesterday. We talked about the tech today, and tomorrow it's about the digital. It's about how to we got Mary back from the first day, talking about change and how to drive that change and really get the projects going. We're going to talk about accessibility. AWS is coming back, and extended reality, and so much more. So I'm really looking forward. Happy to see you again tomorrow in the chat or walking around, like I said, in the VSF. If you have still no clue what the VSF is, just go to openslava.sk, register. You can still do it. It will tell you all about it, and then you will be there physically, digital-wise, with us tomorrow for the last day of this OpenSlava 2021. Checking everything's okay, checking with my backstage crew. They also say okay. So I was Marnik Vandenbroek. You all were great. I wish you a pleasant evening, and hopefully see you tomorrow. Bye-bye.